And if there are no issues, concerns, problems, we get the screen share set up. Hopefully Jesus will be coming in on the whiteboard. Well, there it comes. And now I'll move people around. Kara is slightly in the way here. Not too badly, but let me move you to the right a little bit. Let me get the toolbar up on top, moved over here, and the toolbar down at the bottom. If I can get it to come up here, scooted down here as low as I can get it. Okay. Then I will scoot the whiteboard to the up and left as far as possible. So I have the maximum amount of white space. You know these matrices take up an awful lot of room. Okay, there we have. So again, I'll ask any questions, issues, concerns, either to do with linear algebra or anything else. Now, let me say this, just a couple of issues. Number one, I've started seeing a lot of messages come out about tutoring services, Space Center, those kind of things. I would hope that some of you might consider being tutors, because you've been through every math course we got just about, and you certainly are well qualified to tutor. Okay, that's one thing. Another thing, and this I think especially relates to the two of you, I think the three of you, if Jesus is listening to this later, is they have opened up applications for graduation. Aren't both of you basically very, very close to graduating? Isn't this term it for you? Yes, I thought so. Kara, you too? Okay. Have both of you applied to graduate? There's a few steps that have to be taken there, so be sure you get them all done. So there's a message that went out, an email that went out to all students. So please check your email and find out all that you need to do to be, here comes Jesus. His name here is Miguel, but we know who he is. He's trying to travel incognito. Okay. Perfect attendance today, and that's great to see. By the way, this has been a very good attendance day. I think 2 people were missing out of my 28 students that were left in my first class, and I think only 1 person was missing of the probably close to 20 people that were in my second class. So it's really a fantastic attendance day. All 3 of you are here. Glad you're here. And yes. Do I know what? When they're going to be mailing out financial aid, is that what you said? Okay, you mean deposited in your direct deposit or something like that? Okay. Okay. I can't quite determine, well, number one, I don't know if I know the answer to it because I don't mess much with financial aid. I do know that on the calendar they send out from the administrative services, they say that student refunds are done every Thursday. Now, what that means, I don't know. I don't know if that means they put them in your direct deposit then. I don't know if you can come by and pick them up as a check then. I don't know how they're doing it. Now, what I heard you say something about the bookstore, is the question, is the financial aid information already been sent to the bookstore? Is that what you meant? Uh-huh. Okay. So you need to get on Cengage Unlimited for this term. Is that what you're saying? Okay. And you're needing to purchase another Cengage Unlimited just for this term. Is that what I'm understanding? Right. And yeah, for per term, I think it's what, $115 or something like that. And that covers all the books you have. That would be your calculus book, which you probably already, well, unless you, that would include the calculus book, the linear algebra book, and the differential equations book. They would all be covered under that. And if you didn't, if yours expired at the end of summer and you just need one term, yeah, and you're asking, has financial aid information been given to the bookstore so that you can purchase that? Is that what you're saying? And okay, so you're on a free one that expires next month. Is that right? Okay. All right. I don't know the answer to that. I was afraid I didn't because it's financial aid stuff. But here's what I would suggest. I know there's some email that you can send to the bookstore. I'm just not absolutely sure what their address is now. There's probably a phone number you can do. Um, but if I were looking for those, I would go to the Lawson State webpage, and there's the My Campus up at the top, but then sort of below that and in light blue there's one that says My Lawson Campus. My Lawson's the tab up top. My Lawson Campus is sort of below it and in a lighter blue. And if you click on that and scroll through it, you'll just see tons and tons of icons. I'm almost certain one of those has to do with the bookstore. And I bet you at least one of those has to do with financial services. So you could go to either one of those and probably find out the answer to your question there, or you'll find out someone you can contact, a phone number, an email, or something, or maybe they'll describe it. I don't know. If you can't find anything in all those, you scroll through and scroll through. When you get near the bottom, there's one down there. I think they're like 5 across. Okay, 5 across. On the far right hand side, near the bottom, there's one that has like 4 or 5 students holding up a placard, and every one of them has a big question mark on it. When I've got something I don't even know who to call or ask for it, I go to that one and say, here's my problem. Someone's going to read that problem and get it to someone who can answer the problem, and they'll get back in touch with you. So if you can't find it on one of the icons there, they're little blocks, 5 across, and just, row after row after row of those, until finally near the end, the one on the far right, near the bottom, is those with question marks on it. If you can't find it anywhere else, ask that one. And I think you'll probably be able to get your answer there. Okay. That's a pretty sorry answer, but it's all I got for you now. Okay, sorry about that. And Jesus, before you came in, I was saying I think all 3 of you are graduating this term. Is that not correct? Okay, if you pass this course anyway. Okay, you got 3 really bad math courses, terrible instructors. Okay, so if you can get through them, you'll be okay. The applications for graduation, they're now receiving those for graduating this term, and it's probably a good idea to get those in as soon as possible. So check your email. I saw the email this morning. It either came in today or yesterday, I think. So check your email and find out all the steps you have to take. Be sure you get those done. Okay, that's probably for all 3 of you. Okay, and anyone else that probably is graduating. And you're in several classes with other people that are probably graduating too. So spread it around among your friends and even those people you don't like to. No, I'm just kidding. Yeah. Yeah, there is a thing called the graduation application. It's like a 2 or 3 step process, so you have to do, yeah. It probably is either on My Lawson or My Lawson campus, but I know it's on an email that was sent to all students sometime in the last 2 or 3 days. Oh, you did? Okay, well you may be good. You can check with, and I know that one. And by the way, going back to James' question, I don't know the bookstore's email address, but I do know financial services. It's FINAID at lawsonstate.edu. FIN for financial, AID for aid, FINAID at lawsonstate.edu. They will probably have the answer to your question you were asking too. I can give you that one, and that would be for Jesus. For Jesus, I would say go to records, RECORDS, at lawsonstate.edu, and that's where you're asked if, say, I submitted my application for graduation however many weeks ago or whenever it was you did it. Is everything in order? Do I need to do anything else? And they'll get back to you, I'm sure. They're really good at that. Okay, good deal. Any other questions, issues, concerns? All right. Bottom line, check your emails, because a lot of good stuff is coming out. And actually, also, before you came in, Jesus, I was saying that I've seen some coming out from tutoring services, Space Center, some places like this. And in my mind, the 3 of you and some of your cohorts are probably some of the best people to be tutoring other students. And I bet you they pay. So if you want to look into that, look into it, because I know there's people who probably need some help out there, and I can't think of any people more qualified than the 3 of you and those others that you hang with. Okay. All right. Any other things before we get going on linear algebra? Okay. We're in chapter 2, which is matrices, in section 2.1, which is operations with matrices, and we've done page 40 and on the top of page 41, and here we're looking at matrix addition, subtraction, and scalar multiplication. Okay, now last time we talked about, let me see if I need to charge my phone. I used it some last time, and let me go on and put it on a charge in case I do need it. I don't think I'll need it this time, but in case I do, it'll be fully charged. Let me get my Wacom pad down here. Actually, I don't think I'll need it for this quite yet. I think what I'll do is type some. And let me ask this question. Do all 3 of you have access to books now, or do I still need to be typing and writing some of this stuff down? Anyone does not have access to a book yet? Excuse me. All of you have it? Any of you not? Give me some sort of answer. Yes or no. You got it or not? Okay, Jesus, I saw your lights on. Do you have? I don't know what to say, yes or no. I was just gonna say anything. Oh, okay. Well, you don't have access to a book right now, or it may be it's an ebook, but you can't do it while you're on the phone. Is that right? I mean, I can do it, but I'll just... No, that's all right. I'm just asking, do I need to type this stuff in, or can I just call it out, or you're reading it in your book, you got it there in front of you? That's what I'm asking. Would you rather see it typed out? Huh? So I just have the ebook. So it's not in front of you now. Okay. Let me go on and do it then this way. Okay, so I'll type this out. Now understand this is somewhat limited in what I can type. Now, what we're talking about here, matrix addition, subtraction, and scalar multiplication. If you're trying to add 2 matrices together, number 1, they've got to be the same size. A 2 by 3 cannot add to a 3 by 2. Even though they have the same number of elements, they're not in the same locations. So they have to be precisely the same size. Okay? Then what you do, you add the corresponding elements. That's what you do. So here's that first definition, okay? And I can't type it all, but I'll type what I can. If capital A is equal to, that's a matrix, and this is the way we represent it, open bracket, little a, ij. Now those should be subscripts. I can't do subscript on this screen, okay? I can't figure out how to. I don't think it is. And B, capital B, which is open bracket, bracket, I think they call that. B, and these should be subscripts, ij, close bracket, are matrices of size m by n, so they're both of the same size, then their, I can't spell today, okay, sum, you can add them together, is sum without an E today, okay, don't know what's wrong with the old gray cells today. The sum is the, I don't like the, but I'm saying, the m by n matrix, and how we represent that is A, cleverly, plus B, okay, which is equal to, cleverly, open bracket, Aij plus Bij, and close that bracket, okay. Okay, the sum of two matrices of different sizes is undefined, meaning you can't do it. You cannot add two matrices that are not the same size, period. Can't be done. Okay, so if you have one matrix A, Aij, another matrix B, Bij, and they're matrices of precisely the same size, same number of rows, same number of columns, absolutely same size, then their sum is also an m by n matrix, m rows, n columns, and it's just simply A plus B, should have had a space there, which is the ijth element of A plus the ijth element of B, ijth element of A plus ij. Every element, corresponding elements, get added together to make the new ijth element of the new matrix A plus B. And you cannot add two matrices of different sizes, period. Can't happen, cannot be done. Don't try it, okay? Okay, so let's see if we can do example 2. All right. Let me get my Wacom. We'll do example 2 here. This is 2A. -1, 2, 0, 1. Add to that matrix 1, 3, -1, 2. Can you add those two together? Yay or nay? And yes. And you'll get what size? No, 2 by 2. You get exactly the same size as these. They have to be the same size. The sum has to be the same size. What would be the first entry? 0. Next one. Next one. Next one. 3. 1 plus 2. Right? Okay. So 0, 5, negative 1, 3. Yes, you could add those two. How about the B one here? B is 0, 1, negative 2. 1, 2, 3. Add to that. 0, 0, 0. 0, 0, 0. Absolutely, you're on the money. 0, 1, negative 2, and 1, 2, 3. So my question to you, did this one have to be the same size? Since they're all zeros, wouldn't that add anyway, no matter what size you had? No, they have to be the same size. This is called the zero matrix, okay? Anytime you add a matrix A to the zero matrix, you're going to get matrix A, exactly what you said, okay? Now, how about this one? Here's C. This is called a column matrix. It can also be called a column vector. 1, negative 3, negative 2. And we're trying to add to that negative 1, 3, 2. And what can you add those two together? 0, 0, 0. It will be the zero column matrix. That's a 3 by 1 column matrix or column vector. Okay? Now, later we'll give names to these. These are called additive inverses of each other. That means that you add one to the other, you get the zero matrix, then one of these, either one of these is the additive inverse of the other one. Okay? So, yes. And then there is a D one here. Let's see if we can get this one here. Here's D. That would be 2, 4. I'm writing them this way because it's easier. 1, 0. And 0, negative 1. And let's add to that 0, 1, negative 1, 3. What would that sum be?
That wouldn't work.
Yes, exactly. Undefined. Does not work. You're absolutely right. No solution. There is no matrix. You cannot add two matrices of different sizes and get an answer. Won't happen. Now, one other little thing here, and maybe I should go to a clean slide. All right, to erase this one? Okay. Now, I'll say this. When working with matrices, when we're talking about real numbers, okay, and so far most of the elements in a matrix have been real numbers, okay, but when we're talking about a real number, whether it's in a matrix or not, well, generally not in a matrix, we refer to that as a scalar, okay. Now, back when you do vectors, a scalar meant you're sort of scaling it up or scaling it back. That's why we call it a scalar. We use the same terminology here, but in a sense, you are sort of still scaling, okay? When working with matrices, real numbers, especially that are set off by themselves, are called scalars. So what if you were going to multiply a matrix A by some scalar C? How would you do that? Well, you multiply every element in A. It may have been a 7 by 12 matrix or 7 by 12 matrix. You multiply every element in there by that number C. Okay, that's what we mean by scalar multiplication. So here, let me go and formalize that in a definition here. Okay, if A is equal to bracket A, and these are supposed to be subscripts, IJ. Goodness gracious, this isn't working well today, is it? Okay, close bracket. Is an M by N matrix, and C is a scalar, then the scalar multiple of A, I don't know why it did that. Okay, scalar multiple of A by C is the, again, it's going to be the M by N matrix CA, and that CA is going to be equal to, open bracket, that C multiplied by every one of those Cij's. Every element gets multiplied by that C. Okay? Every one. I mean, not just one row, one column, all of them. And how in the world the matrix wound up with two M's in it, I have no idea. The old fingers are not doing too well today. Okay, so if A is a matrix, Aij, those are supposed to be subscripts, is an M by N matrix, C is any old scalar C, any old real number C, then the scalar multiple of A by C is also an M by N matrix, and the CA is C, every element in Aij in that matrix is multiplied by that number C. Now, let me do a little writing here. What would we mean then by something like this? Minus A. What do you reckon that means? Really, it's the same thing it means in arithmetic and everything else. You multiply A by the number minus 1. Okay? In other words, you negate every element in A. You just multiply every element in A by a minus 1. That's a really ugly minus 1. That parentheses sort of ran together. Okay? Now, let's imagine that we have two matrices, A and B, and we know they are the same size. Okay? Now, what do we mean by A minus B? Any idea? Well, what if we had, give me a number, any old number in the world. Make up a number. 7. I'm going to subtract from 7 the number, give me another number in the world. Give me a number. Any number. Help me, somebody. Give me a number. There's plenty of them out there. 10. Let's just make it a minus 10, okay? What if I was going to do that subtraction? How do I do that? Multiply what? The minuses? Yeah. You add to it the opposite of this number. The opposite of negative 10 is positive 10. And that would give you 17. Right? Well, that's what you do here too. You take the A and add to it the opposite of B. So you add to it minus 1 times B. So in other words, you negate every element in B and add it to A. So the same thing you use with the rules for adding signed numbers, they applied to matrices as well. Matrix subtraction, which is what this is defining here, is take the first matrix and add to it the opposite of everything in the second matrix. That's what you did here. Take the first number, when you're subtracting a second number from it, add to that the opposite of this number, and that gives it to you. If this had been just a 10 here, then this would be plus a minus 10, and that would have been a negative 3 then. 7 plus a negative 10 would be negative 3. So you see how that works. Same thing with matrices. Now, let's do example 3. I think we've got room for it. Here are two matrices. Here's matrix A is 1, 2, 4, negative 3, 1, negative 1, no, negative 3, 0, negative 1. This aggravates me. Why it does this, I have no idea. Okay. 2, 1, 2. It's a defense we used to run in basketball. Okay. Zone defense. And you have this other matrix over here, B. And B is 2, 0, 0. 1, negative 4, 3. And negative 1, 3, 2. Okay. For these two matrices, A and B, find 3A. What would that be? Can you even do that? Sure you can. What size matrix will you wind up with? 3 by 3 matrix, exactly. What would be the elements of that matrix? 3. Yep. 2. Multiply every element by that. Wait. You multiply every element in A by that scalar. Okay, gotcha. Yeah. What would be the next one? Help me, somebody. Oh, my bad. I was on mute and I was talking. It's 12? 12, okay. Next one? Negative 9. Perfect. 0. Good. 3. Negative 3. 6. 6. 3. 6. Got it. Okay. That's how you do scalar multiplication. Multiply that scalar by every single element in the new matrix, in the old matrix, to get you the new matrix. Okay, and that's what they got: 3, 6, 12, negative 9, 0, negative 3, 6, 3, 6. Okay, the second part here says find minus B. So what in the world would be, where in the world is my pen? There it is. What is minus B? Can you do that? The answer is sure. What? Negative 2. 0. 0. Got it. Got it? Got it? Got it? Perfect. That's the negative of b, or opposite of b. Okay. Now the third one, they sort of make it really easy on you. What is 3a minus b? Ooh, those are ugly. Well, you already got what 3a is right here. And then you add to that minus b, which you've got right here. So what would that give you? Boy, that's ugly. I don't think I can handle that. Let's see if I can make that look a little bit better. Okay, so what would you get there? 1. 6 plus 0. 6. 12. Next. Second. Negative 10, isn't it? Because this is your minus b, you're adding them. Well, minus b added minus 1 makes it okay, right, okay. Okay, if you're doing that, you do 3a here minus the 1 here. And that would be negative 9 minus 1 is negative 10. But if you're doing 3a minus b, then you're just adding 3a to minus b. Okay, so you're just adding those two. So that's a negative 10. Four, yeah. Perfect. Next. Got it? Got it. Perfect. Let's see if the book got it. 1, 6, 12, negative 10, 4, negative 6, and 7, 0, 4. Okay. And I guess we got the others right too, because it wouldn't have come out correctly if we hadn't. So yeah, all those were right. So there's example 3, bottom of 41. All right. Now, those were the easy ones, folks. Okay. And none of it's hard, but some of it's a bit more tedious than other. I don't know, that phrase I just said almost reminds me of Animal House. I don't know if you remember that. Said all animals are created equal, some are just more equal than others. Well, I wanted to say this stuff is easy, but some parts are easier than other parts. Okay, so sort of a reverse of that. How in the world would you do matrix multiplication? And let me give you a hint. You don't just multiply the corresponding elements together. That would be too easy, but that doesn't work. Okay, so matrix multiplication, very different from matrix addition, very different from matrix subtraction. Now, how they go about telling you how to do it is with an example. Okay, so I'm going to clear our screen here, and here's the example. Okay, oh, I knew James left, but now I see he's coming back. Good for him. Okay, now what we have, we're doing not an example that you work, but an example they're showing you, giving you an idea how matrix multiplication works. Let's say we have a football stadium. Okay, this football stadium has a south stand, a north stand, and a west stand. To the east, it opens up to nothing. No one sits over there. This is a small field. Okay, maybe high school, perhaps. On the north east side, there's nothing there. But they also have and they have a concession stand on each of these, in each site. Okay, now in the concession stands, in every concession stand, if I could get my pen to move, there it goes, they sell peanuts, they sell hot dogs, and they sell sodas. Now this must be from somewhere other than the South. In the South we say they sell Coke. You know, no, I mean, some parts of the country they say pop. Okay, we don't usually use that either. Okay, now here's the matrix representing the sales that they had at these three concession stands of these three products. In the South stand, they sold 120 bags of peanuts. They sold 250 hot dogs. The crowd was hungry down there. Okay, and they sold 305 sodas or drinks. Okay, this is high school. They're not selling any alcohol. Okay, never mind. They sold 207 in the North stand peanuts. They sold 140 hot dogs. These are a little bit healthier eaters in the North stands, but they drank a lot of soda, 419. Now I can imagine that because the North stands would have the South sun shining down on them, where the South sun would have a little bit of shade from the stands there perhaps, so they wouldn't have the sun in their face, so maybe that's why they drank more. I don't know, I'm just making this up. In the West stands, now that's the small stand, they only sold 29 bags of peanuts. They sold 120 hot dogs. Boy, those people were hungry for hot dogs. Okay, and they sold 190 drinks. Okay, now we're also going to represent the dollars. Okay, that's what the bottom line is, right? And we're going to represent these dollars for the peanuts, the hot dogs, and the sodas or drinks. Okay, peanuts are selling for $2 a bag. Hot dogs are selling for $3 a hot dog. What a rip. Okay, and the sodas are selling for $2.75. Now that is the biggest rip. Okay, but if it's a hot day, they're going to make a lot of money on those sodas. Okay, now how would you determine the total revenue you got from these sales? Okay, well, what you would do was multiply the number of bags of peanuts in the South stand by how much a peanut costs in the South stand. Okay, so what you're going to have here are now dollar values. You're going to have these be your stand still, and this is going to be the amount of revenue you got from those sales. Okay, and what you would do from all the sales in the South stand, you did, there it is, 120 times 2, that would be 240. I don't have enough room to do it up there, so 240 plus 250 times 3, so that's plus 375, plus, I think that's a 305 times 2.75. I don't have my calculator handy. Let me get it. Okay, I was afraid I might need it. Okay, so I'm just going to do this as I go. Let me get my phone turned back on again. Get calculator mode up here. Oh, James must have had to pop out and pop back in again. Could be his computer. It may be something that's going on. Welcome back, James. So he's still connecting. Okay, so basically what we're going to do is 120 times 2, we already did that, 250, no, 240, I can't add, plus 250 times 3, that's 375. No, it isn't. Where in the world did I get that? 775. Glad I pulled out my calculator. 250 times 3 is 990. Where in the world did that come from? 990, okay, plus, that doesn't seem right, but I guess it is. That would be, no, okay, that went on and added them together. That was 750. And when you add those together, you get 990. Okay, that's right. Plus 305, this is one I wasn't going to do in my head, times 275 equal, and I got a total of 1752.50. Didn't leave enough room to write it. 1752.50. No. How did I mess that up? Let me try it again. 240 plus 9, I must have typed it in, or that was 990 plus, I hope that's 305. Yeah, 305 times 275. 305 times 2.75. That may be what I did. 2.75. I got big fat fingers on little bitty keys here. Yeah, that's 1828.75. Now, I'm going to clean this up some. Okay. 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 1828.75. Okay. That's how much the South Stands made total. Now notice how we did that. Now this is, I wish I had two pointers that I could do at once. What we're doing here is multiplying this row by that column. 120 times 2 plus 250 times 3 plus 305 times 275. That gave us our total here. North Stands would do the same thing. 207 times 2, that would be 414 plus 140 times 3, I think that's 420 plus 419 times 275. I can't do that one. 419 times 2.75 equal, and that came up 1986.25. Good, the book got it too. 1986.25. Okay. West Stands, much cheaper people or fewer people, whatever. That's 58 plus 360, and then plus a number I can't do in my head. So 58 plus 360 plus 190 times 2.75. And I got 940.50. Yeah, that's what they got. 940.50. Now, they set it up for you, and of course it came out the way they wanted it to. They set it up. But that is a very good illustration of how you do matrix multiplication. You don't multiply item by item. You do a sum. Now, You're multiplying some things, adding other things. Now, I look at it this way, and this may or may not be good for you, but let me just give you. Let's just take a number like we just had, like 419, if I can get my pen to show up, 419 multiplied by 2.75. Now, if we were doing this good old long multiplication, what do? We multiply this one by that one. That would be a 45. Plus 5 and 4 is 9. Plus, and then we write down a 20 here, right? Then we do this one. 63, 13, 29. Then we do this one. That's going to be 8, 38. And then we add. This will be a 1, 1. This will be 15, I think. This will be 12. That will be 2 and a 5. I don't know if I did the math right, but anyway. Okay. But what were we doing? We multiply each thing here by this one. Write that out here. Each thing here by that one. Write that out here. Each thing here by that one. And write that out there. And then we add them together. That's why we've always done multiplication. We multiply some things together, add other things together. Well, that's how we do matrices too. We multiply the row here by the column here and add the results together. Multiply the row here by the column here, add those results together. Multiply the row here by the column here, add those together. Now, I'll show you another way to think of this. What was the size of this one? A 3 by 3. What was the size of this one? A 3 by 1. You're multiplying those two together. The only way you can make them work if the number of columns here was equal to the number of rows there. 3 columns here equal 3 rows there. That works. What's your answer? It's going to be a 3 by 1, and that's exactly what we got here. A 3 by 1. I shouldn't put it in bracket, but I did. Okay. Now, that's one way. One thing to note. The other thing to note was if I could get my pen to show, there it is. Okay. We had here a this was a A11, A12, A13. That's what we call that first row right there. And here we had a B1, B21, and a B31. That was this column here. And when you multiply those together, you do A1 times B, A11 times B11. These two have to be the same. The inner ones do. Yuck. Okay. Okay. The inner ones have to be the same. This inner one and that one. And what you have is a 1, 1 left. So over here, we had C11. When you did the next one, I'm sorry, that's not totally C11. Then you add to that A12, B21. Again, these two have to be the same, and you still got an A11 or AB11, so that's add that one another C11, let's just call it that. And when you multiply this one by that one, again the inner ones have to be the same, and you got a AB11, so we'll call that plus C11. And that's exactly what we did, and that made your entry for the 1-1 entry here to be C11. Now those were different numbers. I'm not trying to say they're the same numbers, but that's what we were doing. And when you did the next one, that would be an A21, A22, A23, and when you multiply this one by that one, again the inner numbers have to be the same, and you get an A21, and that's the right position here. Let's just call it C21. Yuck. And when you multiply this one by that one, again the last one here equals the first one there. There it is. And you get an A21 again. So here's another, you add to that another C21, I'm sorry. And then you do the same thing here. The 3's go out here and here, and you have AB 31, which is 21, I'm sorry, a C21. This is getting too C21. So all these basically are wiping out the middle things, and you're adding together the things out of the sum subscript. You could do the 3 ones too. I don't know if that's helpful. Maybe it's confusing, but anyway, that's how we do it. So here then is our definition of matrix multiplication. If you thought my description was terrible, I don't think I can type this. Maybe I can type part of it. Okay, so I'll start with the typing here. It's easier to read, I'm sure, but it's going to be pretty awful. Okay. If A is equal to bracket Aij, which should be subscripts, close bracket, is an M by N, I just did them by, yeah, I did them right, M by N matrix, and B is equal to, how are we doing on time? We go to 12:45, right? Yeah, okay, because I've got another class starting at 1:15. I don't have a lot of time. And that's open bracket B, Ij should be subscripts, close bracket. But this one is an N by P matrix. Then the product AB is an, now here's what you do. To multiply this one by this one, the number of columns of this one has to equal the number of rows of this one. So you just sort of wipe those out, and that gives you a product being an M by P, what's left on the outside. You wipe out the inside, they have to be the same, and you get what's left. So this will be an M by P. Where in the world is that? Okay, it's up there. Okay, should be down here. And M by P matrix, and that matrix will be AB is equal to, and like I was saying, Cij, those should be subscripts. Okay, Cij's where, and this is where I have to stop. Okay, so I'm going to stop this for a moment here. Got to write the rest of it in because there's no way I can get the rest of it to work. So let's get my drawing here, get my board. Here's what Cij is. Cij, and this is still not writing well. Cij is the summation, back to summations, when k is equal to 1. This aggravates me. Okay, k is equal to 1 up to n of aik times bkj, okay, and that would be the summation of ai1 b1j plus ai2 b2j plus ai3 b3j plus dot 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 plus, let's see if I can get it in here, ain b n j. Okay, that's it. Now that's what we were doing before. If this looks squirrelier, it is. It really is. But that's what the Cij's are. It's the product of the kth, where is my pen? There it is. Okay. For the ith and the jth thing of C, and I'll show this, and it makes more sense when you do it. The I from the A, the J from the K, from the B, and then you have to have the same row number here, column number here that you have row number there, and you just sum all those up. Okay, that's the formal definition of it. That definition means to say that the entry in the ith row and jth column of the product, you multiply the entries of the ith row of A by the corresponding jth column of B, and add the results as you go. Okay, and we're going to go to the example, and let's see if we can get this one done. Let's see, I think we probably can here, so let's do it. Here's matrix A, and this is a 3 by 2, -1 3, 4 -2, and 5 0. And we're going to multiply this by B. Now B has got to have 2 rows. Got to have 2 rows because the number of columns here has the equal number of rows here. And sure enough it does. -3 2 and -4 1. And by the way, it can have any number of columns, any number. Okay, there's no limit there, but it has to have exactly 2 rows, and A has to have exactly 2 columns if B has 2 rows. A could have had any number of rows, okay, but it has to have the same number of columns as B has rows. Now here's how I do the multiplications. Okay, now I'm going to do them as they are. Just pretend that this is out of the way now. Multiply this by that. Here's where I start. I say, can we multiply it? This is a 3 by 2. This is a 2 by 2. Because these middle 2 numbers are the same, you can throw them away. Your answer over here is going to be a 3 by 2. 3 rows, 2 columns. And literally, I'm not just doing this for now. This is how I do every one, at least until you're really used to them. Okay. Now here's what I do. I sort of do the same thing they do, but turn it around a little bit. I say, what is the address of this entry right here? First row, first column. So I take the first row of A and multiply it by the first column of B. Item by item. -1 times -3 is a +3, plus a 3 times -4, which is -12, plus 3 minus 12 is -9. That's what goes there. What's the address here? First row, second column, so I take the first row of A times the second column of B. Okay, so that'll be a -1 times 2 is -2, plus 3 times 1 is 3. That's just going to be 1. Do you see what I'm doing there? Look at what the address is here, right here. This is second row, first column. So take the second row here by the first column there. -12 plus 8 would be a -4. This is the 2-2 entry. So second row here, second column here. That would be 8 minus 2 is 6. And third row, first column, third row here, first column here. That'd be a -15 plus 0 is -15. And third row, second column here would be third row here, second column here. That would be a 10 on that side. If I can find the pen, there it is, 10. Let's see how we did. -9, 1, -4, 6, -15, 10. Yes. Okay. That to me is the shorthand of how to do this. First, get the size of this one, size of that one, make sure you can multiply them. Those inner two things have to be the same. Number of columns here has the equal number of rows there. If they are, wipe them out, and that gives you this to be a 3/2 answer. So I put blanks in there. 3 rows, 2 columns. Okay, 3/2. And then I ask, what is this entry? It's the 1-1 entry, so I have to do the first row here, first column there. Multiplying and adding as we go. Then 1, 2. This one right here would be first row, second column. That means first row here, second column there. And go to it, adding the things as you multiply. Does that make sense? All right, I hope so. Now, by the way, before we leave page 43, there is a little blurb there on Arthur Cayley, a British mathematician credited with giving an abstract definition of a matrix. He was a Cambridge University graduate, a lawyer by profession, and he began his groundbreaking work on matrices as he studied the theory of transformations. Okay, I'll let you read on. There's also 2 mathematicians, American mathematicians mentioned, Benjamin Peirce and his son Charles S. Peirce. They worked with Cayley. Okay. They came up with developing matrix algebras. This little blurb here cannot be your source for your paper. It can be your idea for your paper. For instance, who in the world was Arthur Cayley, or who was Benjamin Peirce, who was Charles Peirce? Those are 3 possible topics. What was the theory of transformations? You might look at that. Matrix algebra, that's what this whole section's about. You could get several topics out of there. This is not your source. It's the source of ideas, but not the source for your paper. All right. Probably talked too much until we almost ran out of time. The top of page 44 is a really complicated issue, and I think we'll wait till next time to do it. It just takes a long time to write out. We don't have but a minute. So we'll begin at the top of page 44. Okay? Now, homework exercises here. We didn't quite get as far as I'd like, but I think by next time we'll be through with this one. I think you can do either 1 or 3. This is on page 48. They should both be at Calc Chat. You can do any of the odds 5 through 9. They should all be at Calc Chat. I think you can do any of the either 11 or 13. They should both be at Calc Chat. And if you wanted to, you can get started on 15 and do a few of those. We're going to do a lot more of those before we get through. So if you don't want to do all those now, you don't have to, but you could get started if you'd like. Any questions? All right. Well, I think that did take us right to the end of time of this class anyway. I'm going to stop sharing because I'm sick and tired of sharing. Any questions before I stop the sharing here? None? Let me also say this. I think all of you were in class yesterday when I mentioned it, but you know, Kyle in our Cal 2 class, he came down with COVID. So far it looks like it's going to be a pretty mild case, which is very good for him, but who knows how many of his family members, girlfriend, other things like this he may have had contact with before he knew he had it. So be very careful, people. It's there, it's waiting, it can strike when you least expect it. So anyway, with that, I'll end the meeting. Any last thoughts, parting shots before we go? Okay, if not, I'm trying to end it, but it won't. There it is. So I'll end it for all of you. Take care. We'll see you Thursday. Well, we see most of you tomorrow, and I'll see all of you tomorrow, and the 3 of you on Thursday. All right, take care. Bye-bye.